Hello students, welcome to this particular session. In the previous episode we have discussed some numericals based on average speed, average velocity, then how to determine the distance or displacement covered by a body by using VT graph. So we'll continue with that, right? Here are these two questions. Let's consider on the first one. Students, please consider on the first question. The velocity time graph of a body is given. I repeat, it is the VT graph. It is the VT graph. VT graph of a body is given as shown in this board, right? We are supposed to find out the distance and displacement between the time interval t equals to 0 to t equals to 6 seconds. This is the time interval during which we intend to determine the distance and the displacement covered by the body, right? So, it can be divided into three parts, right? And the key point, before we proceed with the numerical, the key point is area under VT graph. It will give us distance or displacement covered by the body. This is the key point. Area under VT graph between any two given intervals of time, that will give us the distance or the displacement covered by the body between those two given intervals of time, right? So this is the concept which we'll be using over here, right? So let's find out the distance. So we need to find out the area under VT graph. So duration is 0 to 6 seconds, 0 to 6 seconds. So we are talking about this area. Let us denote it by 1. This is second area. This is 2. And suppose this is third area. It can be considered to be a combination of rectangle and a triangle. Or as a whole, it can be considered to be a trapezium. So this is the third one. Since the time interval is from 0 to 6 seconds, 0 to 6 seconds, we need to calculate the area of all the three. Right? We need to calculate the area of all the three. So let's find out the distance. So distance covered would be equal to area of first portion plus area of second portion plus area of third portion. So we need to find out the area of all these shaded parts. Right? So in case of first portion, it's in the form of a rectangle. This having a dimension of 2 units and this having a dimension of 30 units. Look, it is 30 units and this one is having dimension of 2 units. So length into breadth. So 30 units multiplied by 2 units. The formula for the area of a rectangle is length into breadth. This is a triangle. Base, it's 2 units. Look, over here 4 and this is 2. So this distance would come out to be 2 units. And what about this altitude? This altitude, that is 20 units. Right? So, what will be its area? While calculating distance, negative sign is to be avoided. Distance can't be negative, isn't it? So, what about the area of the second portion? Area of triangle is half. Base, it is 2 units. Into altitude, altitude is 20 units. Right? Plus, area of the third portion. Students, it's a trapezium and the formula for the area of the trapezium is half sum of the parallel sides multiplied by distance between them. So this is the formula for the area of a trapezium. It is half sum of parallel sides multiplied by distance between them. This is the formula which we'll be using, right? So it's a trapezium. These are the two parallel sides. So formula is half sum of the parallel sides. These are the two parallel sides. This parallel side is having a dimension of 2 units and this parallel side is having a dimension of 1 unit. So it will be 1 plus 2. This is the sum of two parallel sides multiplied by the distance between them. These are the two parallel sides and this is the distance between them. So what's the distance between them? It is 20 units. it is 20 units. This one, it is 20 units. So let's solve it. So it will give us 60 plus 2 to get cancelled. It will give us 20, and over here 10 into 3, that is, it will give us 30. Is it clear? So what we get is 110 meters. Have I made myself clear, students? So while calculating distance, the area are to be simply added up. Always remember, distance is the length of the actual path covered. It can't be negative. So while calculating distance, you simply need to add the areas under the VT graph. That is what I have done over here, right? Now while calculating displacement, displacement as you are aware, it can be positive, it can be negative, it can be even zero, isn't it? Displacement is a vector quantity. So the areas that falls in the first quadrant, they are to be assigned positive sign, while the area that falls in the fourth quadrant, that is to be assigned negative sign. What I mean to say is that, again, area of first plus area of second plus area of third. So what to do is, area of first is 30 multiplied by 2 plus area of second, it is half, base into height, it is minus 20 units. It is minus 20 units. That is why you can directly assign negative sign in the area lying in this quadrant, lying in the fourth quadrant. Clear? So, plus area of this trapezium, it is lying in the first quadrant. All the dimensions are in positive sign. So, therefore, it would be half 1 plus 2 multiplied by 20. Right? The same as was obtained earlier. So, what you get is 60 minus 20 plus 30. That is 70 meters. So, the distance covered by the body during the time interval 0 to 6 seconds is 110 meter, while the displacement covered by the body during the same time interval of 0 to 6 seconds is 70 meter. So, students, the point to be noted is that distance can't be negative. While finding distance through VT graph, we simply need to add the areas. It is of no consequence or immaterial whether the area falls in the first quadrant or in the fourth quadrant. You simply require to add the areas, right? While on the other hand, if we intend to find out the displacement, then only the areas in the first quadrant is to be assigned positive sign, while the area which is in the fourth quadrant, which is having negative dimensions, so it has to be assigned negative sign accordingly, right? So that's the concept involved over here. So using the same concept, let's try another similar question just for practice. Concentrate on that question. That is also a VT graph given. That is also a VT graph given. And we are supposed to find out the distance and the displacement covered by the body during the time interval t equals to 0 to t equals to 8 seconds. I repeat, VT graph of the body is given. We are supposed to find distance as well as displacement during the time interval t equals to 0 to t equals to 8 seconds. So we are supposed to consider from this to this. All the three portions are to be considered, right? Again, I must repeat, area under VT graph that gives the distance or the displacement covered by the body between the two given intervals of time, right? That's the key. So let's find out the distance. It will be area of this portion. Consider to be first. This is area of the second portion, and let us consider this to be the third portion. Let us denote it by 3. So while measuring distance, it's simple. it will be equal to simply area of first portion plus area of second portion plus area of third portion. Simply we need to add up. No need for any sign convention over here, right? Simply we need to add up. Distance is the length of the actual path covered. So we simply need to add the areas. Area 1 plus area of second portion plus area of the third portion. What's the area of the first portion? It's a triangle. So it is half base 4 units. This is 0, this is 4. So it is 4 units. Multiplied by altitude. Altitude is this one. So it is 15 units. Right? Plus area of second. It's in the form of a rectangle. Length into breadth. So this is between 4 and 6. It is 2 units. And over here, it's 5 units. Remember, while calculating distance, the sign is to be avoided. We simply need to add up. Third portion, again it's a rectangle. So this dimension is 2 units. And this dimension is 15 units. So, we can easily solve it. So what I get is 30 plus 10 plus 30. So it is 70 meters. So distance covered by the body between the interval t equals 0 to t equals 8 seconds is 70 meters. We simply need to add up the areas of those shaded portion. In case we are supposed to find the distance covered by the body between 0 to 6 seconds, then this area is to be excluded. 0 to 6 seconds, it will cover only these two areas. So keep in mind the time interval given in the question as well. Right? Okay, let's find out the displacement. Again, between the time interval 0 to 8 seconds. 0 to 8 means we need to consider all the three areas. So in this case, what we'll do is area of first, it will be same. Half into 4 into 15, no botheration. Area of second, now it's in the form of a rectangle or square, length into breadth. So it is 2 units. And over here, it's minus 5. Plus, what about the third portion? Same, it's in the positive quadrant. So 2 into 15, no botheration. So look, this one, this negative sign is to be assigned over here while calculating displacement. So what you get is 30 minus 10 plus 30. So it is 50 meters. So students, again I must remind you, please ensure while calculating distance from VT graph, you simply need to add the areas which comes under that time interval, comes under the given time interval, right? While calculating displacement, we need to ensure that the areas lying in the first quadrant, that is to be assigned positive sign, while the areas lying in the fourth quadrant, that is to be assigned negative sign. Understood? So this is how from VT graph, distance or displacement between two given intervals of time can be easily calculated. I hope it's fully convincing, right? So students, please practice more and more numericals, either from your NCERT textbook or from any other reference book. Let's discuss some other graphical conceptual questions as well. Let's see whether you are able to answer these questions or not. These conceptual questions are based on your theoretical knowledge. So let's see. I am plotting various graphs between different physical quantities. What we are supposed to do is you are supposed to state whether these graphs are practically feasible or not, whether they are possible or not. The graphs are valid or not. That is what you need to state, right? So let's consider the first graph. It is between path length, total path length and time. Suppose it's this one, right? This is the first graph. Second, let's consider it's a graph between position and time. Let's consider it's like this. This is the origin. Third is, suppose this is speed and fourth is, suppose it's velocity and this is time. So these are the graphs between different physical quantities, right? What we are supposed to do is, we are supposed to check whether these graphs are practically feasible or not, whether these graphs are valid or not. Let's discuss first one, right? First graph is between total path length and time. Total path length is what? It gives the measure of distance covered by the body. Total path length is the distance covered by the body. Now look, in this quadrant, with the passage of time, this is okay. But in this case, the path length is decreasing and then it becomes negative. Here, after here, the path length becomes negative. And if a body is moving, if a body is in motion, the net path length of the body can't be negative or it can't be decreasing. It should always keep on increasing, right? So basically this graph is not at all possible because total path length, it represents the distance and distance can't be negative. With the passage of time, the distance covered by a body which is in motion should keep on increasing. It shouldn't decrease. Neither it can have negative value. So this graph is not valid. It is not possible. Let's consider the second graph. Students, it's a graph between position and time. Can you tell me, is that graph possible? Check it. This graph is also not possible. Why? You need to justify it. Look, this is suppose a given instant of time. You can draw a line parallel to the position axis or the vertical axis. Now look. At a given time, the body is at two different positions. Just try to understand the graph, right? At the given time, at the same time, at instant t, the body is at this position also and at this position also. Is it possible for a body to be at two different positions at the same instant of time? Obviously, it is not possible. A body can be at a unique position at a given time. It can't be at two different positions. So since a body at a given time can't be at two different positions, therefore this graph is never feasible. It is not valid. So students, why we are discussing these questions is, I want you to think about the graph. I want to just bring out the hidden facts from the graph simply by observing and just by interpreting the graph correctly, right? Let's concentrate on the third one. It's a graph between speed and time. Again, speed, we have discussed it in detail. It's a scalar quantity. Speed can't be negative. It is a positive quantity. Over here, speed, look, after this time, it is becoming negative. This is the negative quadrant, right? So, after this, it is becoming negative. So, speed can't be negative. So, it is not possible. In case it was given to be velocity, then the graph would have been applicable or feasible in certain conditions, which again we'll discuss in the later section, right? So, presently, the speed time graph, this graph is not possible because speed can't be negative. Fourth one. It's a graph between velocity and time. Velocity, you are aware, it's a vector quantity. It has both magnitude as well as direction. If the displacement is negative, the velocity can also be negative. So velocity of a body can be negative, positive, or even it can be zero. So this represents negative velocity, this represents positive velocity. So obviously, it is possible. So out of the four graphs, only graph D is possible. So I hope you have understood the graphical interpretation. So students, please study consistently and be thorough with your knowledge, right? Try to understand each and every minute details. Anyways, do study these topics thoroughly and practice as much numericals as much possible, right? from any book. So we'll continue in the next session. We'll start with non-uniform motion then.